In this video, we are going to see differential phase shift keying. Differential phase shift keying, it is the non-coherent version of binary phase shift keying. The 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 distinguishing feature of differential phase shift keying is it eliminates the need for synchronizing the receiver to the transmitter by combining two basic operations at the transmitter: differential encoding of the input binary sequence and PSK of encoded sequence. The differential encoding starts with the arbitrary first bit and serving as the reference bit. A symbol 1 is used as the reference bit. The generation of the differentially encoded sequence that proceed in according to the two-part of encoding rules. If the new bit of the transmitter is 1, it leaves the differentially encoded symbol unchanged with respect to the current bit. If the input is 0, it changes the differentially encoded symbol with respect to the current bit. The differentially encoded sequence is denoted by TK, is used to shift the sinusoidal carrier phase by 0 or 180 degree, representing the symbol 1 and 0. And in terms of phase shift, the resulting DPSK signal follow the two part. To send the symbol 1, the phase of the carrier signal is remain unchanged. To send the symbol 0, the phase of the DPSK signal is shifted by 180 degree. And then the generation of DPSK signal. Here the actual input PK. Here this is the actual input PK, and this is the differentially encoded sequence DK. Here we take the reference bit is 1, and then if one delay time bit is DK minus 1. One delay time bit dk minus 1, it is the previous value of dk. Here we consider it is 1. If both symbol is same, at the time the output equal to 1. If both symbol is different, at the time output equal to 0. Here the both symbol is same. This is the reference bit. This bit is goes here. Here both symbol is same. Then the output is 1. Here then the output of this bit is moved here, and then the both symbol is different. Then output is 0. Then this bit is moved here, and then say both symbol are same bit, so output is 1. Then this bit is moved here. Both bit are same. Then output is 1. Then this bit is moved here. The both symbol are different. The output equal to 0. If the both input are same, at the time output equal to 1. If both input are different, at the time the output is equal to 0. And the transmitter pulse is the sinusoidal carrier wave. Here, if the output 1 is, if the symbol 1 is represented by the in-phase carrier, if the symbol 0 is represented by the out of phase carrier, that means 180 degree phase shifted. The phase shift occur if the symbol 0 is transmitted. If the phase shift is not occur when the symbol 1 is transmitted. Basically, the DPSK signal is the example of non-coherent orthogonal modulation. It consider over the successive 2-bit interval 0 to 2 dB. Let the transmitter signal DPSK signal is first bit interval is 0 to dB, and which is correspond to the symbol 1, and second bit is the dB to 2 dB. That value is symbol 1. If both symbol are same, at the time then the carrier phase is unchanged. If both symbol are different, if both symbol are same, here if both symbol are same, at the time carrier signal is not changed. If both symbol are different, at the time the carrier signal is changed. This is the DPSK transmitter. In this DPSK transmitter, the binary input signal is given into the logic network. The logic is nothing but XNOR gate. And then the one delay time of output of logic gate is given by the delay network. And the output of the delay circuit is TK minus 1. This is the TK, and one delay bit is TK minus 1. The input of XOR gate is XNOR gate is same. At the time TK value is equal to 1, the input and TK minus value is different. At the time TK value is equal to 0. Then this is the actual basic binary PSK signal. If 0 is transmitted at the time, and the phase shift is minus 180 degree. If 1 is transmitted, the phase shift is 0 degree. The logic network and 1-bit delay network, which is interconnected to convert the input binary sequence PK into the differential encoder sequence DK, and the binary PSK modulator. The output is taken from the binary PSK modulator, which is produce the desired differential phase shift differential phase shift P. This is the DPSK receiver. In this DPSK receiver, it has in-phase channel and quadrature phase channel. The X of t is given in the in-phase channel and quadrature phase channel. And then this is the decoding circuit, which is used to perform the decoding operation. And then the output is the decision device having the threshold value is 0. If y is greater than 0, then the output is 1. Y is less than 0, the output is 0. Here the implementation is very simple, and it merely requires the sample value to be stored. And the receiver in the figure is optimum for two reasons. In structural term, the receiver avoid the use of fancy delay line, and in operational term, the receiver make the decoding analysis straightforward to handle. It has the two symbol to consider orthogonal each other over the interval 0 to TB to T. Thank you.